Within statistics, we often start off by comparing groups and analyzing groups by only analyzing two different populations. But in reality and in our real world, we will often encounter situations where we will be analyzing more than two populations. So when we want to analyze more than two populations, that is where we have ANOVA come in. So ANOVA stands for Analysis of Variance, and we utilize the data within these tables to analyze the means of different populations to see if there's variance between the means of more than two populations. So if we go through this ANOVA table, first we need to understand what each term means in order to apply these numbers into word problems and real life examples. So we always have a source to begin with. So our source is going to be our group, or it's going to be our error. Now, for our group, let's begin by talking about our degrees of freedom. And we know that the degrees of freedom are going to be very important when we're trying to determine our critical value within our tables. So whenever we have a group and we want to find the degrees of freedom for a group, it's going to be I minus 1. So what is I, and how do we define a group? So let's say that we're running a clinical trial where we have medication A, medication B, and medication C. So we have 3 different groups of medications. And in each group, we are going to have 5 different participants, okay? So our I in this case is going to be 3 because I is the number of groups. So A, B, C, that's 3 groups. I is equal to 3. The next thing we need to understand is what is n and how does that relate to our error? Well, n is the total number of samples that we take. So for example, in this case, we have 5 participants, so we're going to have 5 different samples. So we have 5 plus 5 plus 5, and n is going to be equal to 15, okay? So it's essentially the total number of participants we have within this given situation. So I is equal to 3 and n is equal to 15. Now if we go I minus 1, so 3 minus 1, which is going to be 2, we are going to get our degrees of freedom associated with groups. Then if we want to find the degrees of freedom for our error, we go n minus I, so n minus I, which is going to be 12. Now, for the total degrees of freedom, it's going to be n minus 1. N minus 1 is going to be 14. Now, we may notice over here that 2 plus this 12 gives us the 14. Thus, we get the total. So, the degrees of freedom associated with the group and error, if we add them together, we will get our total degrees of freedom. Now the next thing to talk about is our sum of our squares, and we'll get into the equations later, but first we just need to understand what these letters stand for. So our sum of squares consists of our SSG and our SSE. So our SSG is going to be the sum of squares of our groups, okay? So sum of squares of our groups. Whereas our SSE is going to be our sum of squares of the error. Now, both of these have different equations associated with them, but we'll get into that later. And then we have our SST. Now, our SST is going to be the total of SSG plus SSE. So essentially, SST, which is sum of squares total, is equal to our sum of squares error plus sum of squares of the groups. Now the last column over here is the mean of the squares. So the mean of the squares is actually SSG. So we take the sum of squares of the group and we divide that by the number of groups that we have minus 1. So essentially we're going SSG divided by the degrees of freedom associated with the group. So we can see how within each row, each subsequent column follows a specific pattern. So first we had the degree of freedom, which is I minus 1. Then we found our SSG, and the MSG is going to be SSG divided by our degrees of freedom. So one thing that we should note over here is that when we calculate SSG divided by I minus 1, we will get our MSG. So MSG is over here. In this bottom column over here, we will actually get our MSE. So remember, we're taking these upper letters, combining it with what we see on the side. So we're gonna get our mean square of error and our mean square of groups. Now, over here in our mean square of the error, we can see that it's going to be our sum of squares error divided by the degrees of freedom associated with the error, and we're going to get our MSG. Now, one thing to note over here is that we do not add these two values together because we're given two means, okay? We're calculating the mean of the groups and we're calculating the mean of the error. And we never actually, if we add two means together, that doesn't really give us much information. For example, let's say we have one population and the mean height of that population, the mean age, let's say the mean age of the population is 18, and then we have another population, the mean age is, let's say, 10, we're not going to add the two means together and say, okay, the mean of the both populations is 28. That value, it doesn't make any sense. So we never add two means together because it's not going to make sense. So that's why we see nothing over here. And then over here, we are going to calculate our F statistic. So normally in basic statistics, we're always calculating that test statistic. And in the case of when we have multiple populations, so if we have two or more populations, we can calculate our F statistic. And our F statistic is going to be our MSG, which is right over here, and we're going to divide it by our MSE, which is right over here, and we'll get our F statistic. One relationship that we should have an understanding of is that our normal test statistic of a population of one or two populations is our test statistic. But if we square our test statistic, that will give us our F statistic. So this relationship is also very important to understand. So essentially over here, if we're trying to figure out problems associated with analysis of variance in multiple populations, if we're given a question and some of the data is given in this table, we can figure out the rest of the values only if we're given a couple of the values. And this is just an introduction to the ANOVA table. Later on, we will go over specific questions and the formulas for SSG and SSE.